Assalamualaikum and hello. I'm going to continue in this video about the last part of subtopic 5.1 quantum number of electrons. So in this part, we are going to learn how to sketch and describe the shape of the orbitals that we've learned so far with correct orientations. So which means that in this video, you are going to learn how to draw. So let's go into what you should first know about this thing. So the first thing that you have to know that you've learned about angular momentum quantum number L in the previous videos, where from L value you can determine the shapes of orbital. So I got here the value of L from 0, 1, 2, 3, and we have the symbol of the orbital respectively with the value 0 for s orbital, 1 with p orbital, 2 for d orbitals, and 3 for f orbital. And from this value, you can determine the subshell for the orbital, and also you can determine the orbital shape. So for s orbital, the shape is spherical. For p orbital, the shape is dumbbell. And for d orbital, the shape is cloverleaf. So for spherical, on paper, usually we draw it just like a circle. And for dumbbell, on paper, we are going to draw two loops like this. So this is for dumbbell. And for cloverleaf, usually is just like a flower with four loops. So that's for d orbitals, for cloverleaf. So let's get on with the first orbital, s orbital. So s orbital is represented by L value equals to 0, where we know the shape is in spherical about the nucleus, and the electrons are moving anywhere within the sphere. So when you learn about L value, you can determine the M value, which is when L equals to 0, M equals to 0. So from here, you know that the value 0 is only one value. So it means that one orientation. So from there, you are going to draw based on how many orientations you have for those orbitals. For s orbital, we only got one orientation, so that's why we just have one drawing for s orbital. So how to do that? I give you the step for drawing the orbitals. So how to do? The first step, you have to draw three axes. Axis y, z, and x. So you have to draw based on those axes because we want to represent the orbital shape in three-dimensional drawing, but on the paper. So first thing first, I'm going to draw three axes. So this is my axis where I have x-axis, y-axis, and z-axis. And in the middle of it, we can imagine that this is the center where we put the nucleus. And how we want to draw the shape of orbital, so it's going to be the spherical shape. So I'm going to draw the circle in the middle of it, and then I have to shade my orbital for step number 2. So when I want to shade, I just draw it like this. And you have to label your orbital. In this case, this is s orbital. So that's how you draw the orbital s. But as you can see here, where you should know the electrons. So electron is situated within this area that you shade. So this is what you relate with the definition of orbital. Three-dimensional region where there is high probability of finding an electron in it, but we cannot determine the exact position of the electrons. We just can say that it will be situated within this area. So I go to more upgrade level for drawing, where when my n value, principal quantum number, increases. So what happened to the size of s orbital? It will get larger. So for example, I have n equals to 1, n equals to 2, and n equals to 3. So I got different energy level here because due to the different principal quantum number n. So what I have to do here, I want to show the difference in size for those different energy level. So I have to draw the same shape but different size. So how to do this? So we know from here, L value is going to be the same for all of them. L equals to 0, L equals to 0, and L equals to 0. So right now, what I'm going to do, I'm going to draw the shape of them. So let's go to the first one. The first step, we have to draw all three axes. So I draw for n equals to 1 first. And the next one, I draw for n equals to 2. And the last one, I draw for n equals to 3. So this is my axis. Okay, and the next one, I have to put the arrow on my axis. So each of them mesti ada arrow. So I got here arrow and label my axis X, Y, and Z. And then I can also put X here, Y here, Z here. Depends on your labeling. And then I can also put Z here, Y here, X here. So whichever you comfortable with, at least 3 axis kena ada. So next one, what I'm going to draw, saya akan draw based on n equals to 1, n equals to 2, n equals to 3. So usually I will start with the largest one, n equals to 3. So I will draw the largest circle that I can do. So what I'm going to do, I'm going to draw the largest one for this sketching. Make sure your shape is symmetrical. Okay, and then you shade your orbital. And then this is the largest for my n equals to 3. And the second one, I followed with the a bit smaller than that, n equals to 2. So I draw it like this. And then I shape my orbital. And last one, I draw the smallest one, n equals to 1. I draw the smallest circle that I can do. So this is n equals to 1. So at least when you show your drawing, you should see the difference in size. So the last step, we are going to label our orbital. But please be careful here. You've learned about the general way how to draw the s orbital. But right now, it's not general anymore because the n value is stated here. So it means that you have to be specific. We know that everyone here is based on s orbital because the value of L is same. But right now, the difference adalah n value. So how you want to label? You are going to put the n value first, 1, and then followed by the orbital. So this is going to be labeling for 1s. And then the second drawing, this one, you are going to label as 2s. And the last one, the third drawing, the biggest one, you are going to label as 3s. So that's how you draw in this kind of question where they ask you the difference in the size. So settle for s orbital. I hope you learned something from this one. Alright, settle for s orbital. So I will stop here because I'm going to continue for the next part about how to sketch the drawing for orbital P in the next video. So I'll see you there. Bye.